Transforming a raw pine log into a perfectly squared 20 by 20 timber is a process that combines precision, experience, and industrial efficiency. What looks simple from the outside actually requires careful planning at every stage to maximize wood recovery and maintain structural quality. The process begins with log selection. Pine logs chosen for heavy timber production must be straight, mature, and free from excessive knots or twisting. Operators inspect the log carefully because even small defects can affect the final dimensions and strength of the timber. Once selected, the log is moved onto the sawmill carriage. Modern mills use hydraulic loaders and laser alignment systems to position the log accurately before cutting begins. Proper alignment is critical because a few millimeters of error at the start can lead to major dimensional inconsistencies later in the process. The first stage of sawing is called breakdown cutting. A powerful band saw removes the rounded outer slabs from the log, gradually converting the natural cylinder into a squared cant. These first cuts determine the efficiency of the entire operation. Skilled sawyers always aim to recover the maximum amount of usable wood while minimizing waste. As the log rotates between cuts, each side is flattened with precision. The machinery operates with remarkable speed, but accuracy remains the priority. Pine is softer than many hardwoods, allowing smoother cutting and faster feed rates. Yet it still requires careful blade control to avoid surface tearing or dimensional variation. After several passes through the saw, the log becomes a large square cant slightly oversized compared to the target dimensions. This extra material is intentional. Wood naturally shrinks during drying, and mills must account for moisture loss before the final sizing stage. The cant then moves to the resaw station, where precision cuts bring the timber closer to its final 20 by 20 dimensions. Laser measurement systems continuously monitor thickness and alignment during this phase. Industrial sawmills rely heavily on automation because consistency is essential, especially when producing structural timbers for construction projects. Once sawing is complete, the fresh pine timber still contains a high moisture content. At this stage, the wood is vulnerable to warping, cracking, and fungal growth. To stabilize the material, the timber enters a drying process. Depending on production requirements, the wood may be air-dried naturally or placed inside a controlled kiln. Kiln drying accelerates moisture removal while maintaining dimensional stability. Temperature, humidity, and airflow are carefully controlled throughout the cycle. For large pine timbers, drying can take several days or even weeks depending on thickness and target moisture levels. After drying, the timber is inspected again. Any remaining imperfections are trimmed, and surfaces may be planned for a cleaner finish. The final result is a strong, uniform 20 by 20 pine timber ready for structural applications, heavy framing, bridges, cabins, or architectural wood construction. What began as a raw forest log has now been transformed into a precision-engineered building material through a combination of skilled operation, advanced machinery, and efficient wood processing technology. Closing shot, finished 20 by 20 pine timber stacked in a lumberyard. Narrator, from forest to finished beam, every cut matters. And in modern timber production, precision is what turns natural wood into reliable structural performance.